All right, so this is going to be the second part of 6.1. We're talking still about the law of sines, but we're talking about the ambiguous case where you have angle side side. We call that the donkey case. So we are still using the same essential question of solving a non-right triangle, just we're looking at the third case here. So this is just a reminder, this slide is what the law of sines are and how we draw our triangle. That's from the previous notes. Moving to the next one, this is where we talk about if we have the three cases where it works, where we have angle, angle, side. So if we have an angle, and then an angle, and then a side, that's one case. And then if we have angle, and then a side, and then an angle here, we can do that. And then our last case where we go angle, and then side, and then side. And this is the case that we're going to be looking at today, the ambiguous case. So here are some things that we need to remember about our triangles. First of all, in a triangle, the sum of its angles are 180 degrees. This will become important and you'll understand why. No two triangles can have two obtuse angles. Of course, if you have two angles that are obtuse, that means they're greater than 90 degrees. That means you'd have a triangle with more than 180 degrees, which is not possible. The third thing is the sine of a function cannot be greater than 1 or less than -1. We talked about that when we graphed our function, about how we have a sine curve that goes up to 1 and then down to -1. So that's important to know that it can't be anything greater than 1 or -1. And then the last thing, which we just talked about in the inverse section, is if the sine of an angle is a positive decimal less than 1, then it can lie in the first or second quadrant. So what we had talked about there is with the quadrant saying all students, where everything is positive here and sine is positive here, if you get an angle that's in this quadrant, for when we take the inverse sine, that will also produce an angle that is in this quadrant with the same reference angle. And again, we'll talk about that briefly, but that's something that we just did work on and should be a little bit clear to you that even though the calculator may only spit out this answer, we also realize there can be an answer in this quadrant as well. So let's just get right into the examples here. We have a case where it's an angle side side. So we're looking at b equals 16 and a equals 20, and the angle here is 30. So let's write out what we normally have. So we have a equals 30. We have angle b we don't know. We have angle c we don't know. We have side a is 20. We have side b is 16. And side c is what we don't know as well. So when we set up our law of sines, we're going to do it the same way. We're going to use what we know. We have a pair, 30 and 20 here. So this is going to look like the sine of 30 divided by 20 equals, and then we'll just go ahead and do our angle b here, sine of b over 16, and then we cross multiply, 16 sine of 30 equals 20 sine of b. We have to divide both sides by 20 here to get what our sine of b is. So remember, we're solving for sine of b, not b. So sine of b is equal to 16, sorry, that should be sine of 20. Oh, that's right. I apologize. So we have divide by 20 on both sides. We have 16 sine of 30 divided by 20 is equal to sine of b, which equals 0.4. Now remember, to figure out what an angle is that's with a trig function, we have to use the inverse. So we use a calculator for this. So the inverse sine of 0.4 is equal to b, and b equals 23.57. And we're going to just round that up to 24 for right now. Now, keep in mind, this is where it comes in. This is where we just talked about it. If the sine of a value is in between -1 and 1, we do get two solutions. So the solution that we just came up with is in this quadrant right here being 24 degrees, but we also have a solution in this quadrant right here, which we can figure out. The reference angle is still 24 degrees, but to figure out what the full angle is, we do 180 minus 24, which equals 156. So up here, we would write that b could be 24 degrees or 156. However, one of the things you should notice right away is that we have a problem. We have a problem because 156 plus 30 already gives us over 180 degrees, which does not give us a triangle. We can't have a triangle over 180 degrees. So even though we did get a second solution there, we can cross that out knowing that we're not going to use that. So we can continue on with this problem with the angles that we have. We have two angles here, angle 30, angle 24. So our third angle will be 180 minus those, minus 30, minus 24, and we get 126. So there's our third angle there. So then to figure out our third side, we're just going to use normal law of sines again. So we have sine of 30 over 20 equals sine of 126 over c. Cross multiply, 20 sine of 126 equals c sine of 30. Divide both sides by sine of 30. And put all of this into our calculator, and we get c equals 32.4. So pretty much the same idea for this one as before. The only thing that's different is we're solving for an angle to start out. So this is the first case of a possible ambiguous triangle. We did get a second solution, but we found that that second solution won't work. So let's move on to the next one. In example 2, we're going to almost do the same thing here, but we just have different side lengths. So we have angle 30 still. So let's label everything. A equals 30 degrees. B equals we don't know. C equals we don't know. Side A we know is 7. Side B is 16. And side C we don't know. So again, we're going to go through this the same way. We're going to try and find what angle B is. So we're going to write out sine of 30 degrees over 7 equals sine of B over 16. Cross multiply, sine of 16 sine of 30 equals 7 sine of B. Divide both sides by 7. We end up with sine of B equals, and then we would put 16 sine of 30 over 7 in our calculator. And that equals 1.14. And we do our inverse of 1.14 equals B. And when you put this into the calculator, what's going to end up happening is the calculator is actually going to give you an error. So we get an error. So what does that mean? Well, first of all, why do we get an error? We get an error because our value is greater than 1. We just talked about in one of the previous slides, we have to remember that sign will always be between -1 and +1. So if that's the case, we will never get a solution where it's greater than 1 or smaller than -1. So therefore, we're getting an error. So what does that mean? What does it mean for us to get an error? Well, it means that the angle doesn't exist. So that means this triangle doesn't exist. You know, we can't just randomly put whatever side lengths we want and all of a sudden come up with a triangle every single time. So in this case, because we got an error for B, we're going to say that there is no triangle that satisfies this. Okay, so the first example we got two solutions. One of the solutions didn't work because it put us greater than 180 degrees in our triangle. The second one, we didn't even get an angle, so we have no triangle. So now let's look at a third example. Third example, same idea. We have A is equal to 30 degrees. We do not know what B or C are. We have small a is 10. We have small b is 16. And we have C is equal to, we don't know. So therefore, we're going to go through the same process we did before. So we're going to do sine of 30 over 10 equals sine of b over 16. We're going to do this really quickly because we've been doing this for a while now. This shouldn't be b, that should be 30. 16 sine of 30 equals 10 sine of b. Divide both sides by 10. 10's cancel out, so we're left with sine of b equals 0.8. Now again, to find our angle, we use the inverse of 0.8 equals b. And we get b is equal to 53.13. And we're just going to round that to 53 degrees. But again, now we have to remember that in our quadrants here, we can get a we can get a sine angle in this quadrant, and we can get a sine angle in this quadrant. So we know that this one is 53.13 degrees, or in our case 53 degrees. So we can also figure out what this angle over here would be by subtracting 180 minus 53, and that gives us 127. So that means we can have 53 degrees or 127 degrees. So in this case, you need to state that there are two triangles possible. So we can either have a triangle that's possible with 30, 53, and then whatever we get for our third angle, or we can have a triangle that's 30, 127, and the angle that's possible. So what we're going to do in this case is we're going to just pick one for now. And then what we're going to do is I'm going to have you guys do the other one on your own, and you're going to bring it to class, and you're going to share with what you got. So if we do 30 degrees, 53 degrees, we subtract those from 180. So 180 minus 30 minus 53, that gives us 97 degrees. So this will be 97 degrees. So then to figure out our other side, we do the law of sines. So we have sine of 30 over 10 equals sine of 97 over c. So we get c sine of 30 equals 10 sine of 97. Divide both sides by sine of 30. And we get c equals, in this case, 19.85. Okay, so that is the first answer we would get. Again, what I want you guys to do is I want you to do this one on your own. So now instead of it being 30, 53, 97, I want you to do 30, 127, figure out what this angle would be, and then see how the C changes. So do that on your own. I hope that makes sense. We can talk about this a little bit more tomorrow, but I will see you in class tomorrow. Have a good night, or whenever you're watching this.